Hi to the guys at Teep. As discussed before, putting together a pulse motor that would charge the run battery. This is what I came up with and got some interesting figures. I've used two coils instead of a bifilar one. Got the drive coil on the left and the trigger coil on the right. The trigger coil is adjustable in as far as the timing goes, as you can see there. As you might have heard, it slowed down the closer I got to 180 degrees out from the drive coil. I found it runs the best in that position there. The rotor has two magnets in it, so if it was a bifilar, both coils would be hitting the magnet at the same time, but I've found by moving it around to that position, the trigger coil, that it runs at its highest speed at its lowest current draw. The trigger coil I've got going into a bridge rectifier. Now I'm firing the transistor with what I call the leading pulse from the trigger coil. That's the magnet approaching the coil. The trailing pulse, which is the magnet leaving the coil, I've got coming off the other AC leg and running this LED. Now this LED is rated at 2.5 volts with 20 milliamp current draw. It's currently running at 2.88 volts, so not sure how long it's going to last. It should be okay. It's not a lot more voltage. So that's that side of it. The drive coil I've also got going through a bridge rectifier. The back EMF comes from the positive and the negative of the bridge rectifier and charges this battery. It's a 12 volt battery. When I started, the battery was at 12.02 volts. That was about 10 minutes ago. It's now up to 13.1 volts. Now the interesting thing is, it's charging at about 9 to 10 milliamps. You can see that it's set on the 50 milliamp scale, and yeah, we're definitely 9 to 10 milliamps. So doing some sums on that. If we go over here and have a look, forgot to show you the input voltage. 12 volts, 10 milliamps. Now I know it's 10 milliamps because it's flicking between 0.01 and 0.00, so it's very close to 10, occasionally 11, occasionally 9, so evens out to about 10 milliamps. So if we look here, if we go, our power in is 12 volts at 10 milliamps is 0.12 watts. Our power out is 13.1 volts at 10 milliamps, which is 0.131 watts. Already that's over what's going in, as far as I can tell. Then there's also the LED. So that's a 2.8 volts it's been run at, and I've dropped it down to a 15 milliamp draw, even though it's rated at a 20 milliamp draw. It draws about 19 milliamps through batteries, so that comes out at 0.042 watts. So if I add all them out, the total out is 0.173 watts for a total in of 0.12 watts. Now I may have done something wrong. I've only been doing this for about a year, still learning. I do make mistakes. I'm not saying this is over unity. I am saying that the numbers seem to say that it is. So check it out, guys. I guess you want to see how I've done on paper instead of this mess I've got on the bit of plastic. Okay, well I've pinched a bit of the DAF mans picture because he's done such a good job on that. Hope you don't mind, Daft Man. Modified it, and that's how I'm running it there. As you can see, the 2 coils going into the bridge rectifier, and the way that I've pulled off of the coils to drive the system. So check it out, see what you reckon, let me know.